Ardino Lovometer Project 3 from the Ardino projects book. So I've done projects 1 and 2. You can watch my other videos. So I think I'm ready for this next one. Reckons it'll take 45 minutes, but I can probably, the other ones haven't taken that long. So I've got all my different parts ready out here, because I sneakily look and read ahead a bit. So the Lovometer is using a temperature sensor to measure how warm your skin is. Ooh, computer sliding forwards. Okay. This component outputs a changing voltage depending on the temperature it senses. It has 3 pins, one that connects to the ground, so this is the actual temperature. See, it's got 3 pins. What does it do? It has 3 pins, one that connects to ground, another that connects to power, and a third that outputs a variable voltage to your Arduino. In the sketch for this project, you'll need the sensor's output and use it to turn LEDs on and off, indicating how warm you are. There are several different models of temperature sensor. This model, TM36, is convenient because it outputs a voltage that changes directly proportional to the temperature in degrees Celsius. The Arduino IDE comes with a tool called Serial Monitor that enables you to report back results from the microcontroller using the serial monitor. You can get information about the status of sensors and get an idea about what is happening in your circuit and code as it runs. So I'm just reading out what's in the book to help me understand what's happening. Okay, I've got a nice little build the circuit diagram again, nice and easy to follow. Just as you've been doing in the earlier projects. Wire up your breadboard so you have power and ground. Okay, so getting my red wire, I plug it into the red bus line on the breadboard and I plug it into the 5 volts over here. And similarly with the black one, I plug it into the ground bus on the other negative one on the breadboard and ground over here. Okay. Attach the cathode short leg of each of the LEDs you're using to the ground through a 220 ohm resistor. So this looks exactly the same as what I've been doing before, but I can never remember which way round to put the legs. So let's take this nice and slow so I don't mess it up. Right, so if I put them down here, and so I've got my long legs at the top this time, there. And I'll just stick all of these in with the long leg at the top there, and there. Okay, so that's my 3 LEDs in. And I need to attach my resistors attach the cathode short leg of each LED you're using to ground through, so the short legs, I put the long leg in the top one, the short leg's this one, and I need it in that same line, and that goes there into ground, so the black bus line, and I shall do the same with this one and this one. There we go. That's in. Cool. Then I connect these up. Just pop this back in the middle. Connect the anodes of the LEDs to pins 2 through to 4. So this is on the red leg, the longer leg here. So actually if I put them, because it doesn't matter, it's the whole line. And was it 2 through to 4? So if I start, no, I start with 2. That one goes in. I'll put this one in 2. Oh, there we go. And then put it in the long leg side of that one there, and through to 3. Okay, there. Let's push that in. It's a bit stuck. There we go. And that goes back onto the long leg or the one next to it there. Okay, so that's all done. Now place TMP36 on the breadboard with the rounded part facing away from the Arduino. The order of the pins is important. So the rounded part facing away, so this is the flat side, and then this is the rounded side, that side, flat side, rounded side, Arduino board. Okay, think I've got this. Place the TMP36 on the breadboard with the rounded part facing away. The order of the pins is important as shown in figure 3. So this just goes to the back. Let's put it over here. And I assume each pin has its own space. There we go. Let's do that. Then connect the left pin of the flat facing side to power. The left pin of the flat facing side, so this one closest. No, apparently not. To power. On the diagram it looks different. Maybe it's because it's... Okay, if that was there... Okay, that one is going to power. This one goes to power. This one goes into my power and red bus line. And then the right one goes into the ground, I'm guessing. Let's read that. And the right pin to the ground, yeah, that goes over here. It's a bit fiddly. And then connect the centre pin to pin AO on your Arduino. That's the centre one. And that goes to pin AO. So over here, these are analog in, it says. Cool. So that's all the breadboard made. Let's see what the next page says. The code. Okay, so I shall leave this here for now and go and do some code. Arduino Levometer coding part 2. So I've made the breadboard, and now to code it, I've got a sketch or a program file up, and I'm just going to read through my little booklet to tell me what to do. A pair of useful constants. Constants are similar to variables in that they allow you to uniquely name things in the program, but unlike variables, they cannot change. Then name the analog input for easy reference and create another named constant to hold the baseline temperature. For every 2 degrees above this baseline, an LED will turn on. You've already seen the int data type used here to identify which pin the sensor is on. The temperature is being stored as a float, or floating point number. This type of number has a decimal point and is used for numbers that can be expressed as fractions. So we can put right at the top, const integer sensor pin equals AO, and so that was the one I plugged it into. So A0 where AO looks like. Const float, so this also includes a number with decimal points. Baseline temp equals 20.0. And I finish each line with a semicolon because that's like a full stop. Now, in the setup, you're going to use a new command, serial begin. This opens up a connection between the Arduino and the computer, so you can see the values from the analog input on your computer screen. The argument 9600 is the speed at which the Arduino will communicate, 9600 bits per second. You will use the Arduino IDE's serial monitor to view the information you choose to send from your microcontroller. When you open the IDE serial monitor, verify that the baud rate is 960. So this is then the setup. I'll just go to this one. And this is serial begin 9600. And this is open a serial port. Next up is a for loop to set some pins as inputs. These are the pins that you attached to LEDs earlier. Instead of giving them unique names and typing out the pin mode function for each one, you can use a for loop to go through them more quickly. This is a handy trick if you have a large number of similar things you wish to iterate through in the program. Tell the for loop to run through pins 2 to 4 sequentially. So in the last code I did, I wrote out each pin with pin number and output, but instead there's a quick way of doing it, so let's do it this way. So you start with 4, and I'm looking at integers, and pin number equals 2, semicolon, pin number is less than 5, and pin number plus plus. So for pin number starting at 2, for numbers less than 5, it will loop through them, adding 1 each time. And this is pin mode, pin number, output. So I think pin mode was what we used in the last code. No, it was digital, right. Okay, what is pin mode? Okay, we're just checking if it's output or input, maybe? Maybe we're just setting it. Pin mode. Sure, I've used pin mode somewhere. Oh yeah, setting it up, so I'm just saying if it is an input or an output type. So we set that up at the beginning of the last one. And digital, right, pin number, it's case sensitive, low. So low is no voltage, or 0, or probably off, and we're setting these as an output. So rather than checking what it is, we're going to set them, I think would be my understanding so far. In the loop function, you'll use a local variable named sensorVal to store the reading from your sensor. To get the value from the sensor, you call analog read that takes one argument: what pin it should take a voltage reading on. The value, which is between 0 and 1023, is a representation of the voltage on the pin. So within the